Hi guys, welcome to this set of videos. What we're going to do in these videos is now we're going to look at two more trig functions. We're going to look at the sine and cosine, and we're going to look at how the ratios of a right triangle will allow you to find the sine of an angle, or how the sine of an angle determines the ratio for the sides of a right triangle. So this is just sort of a continuation of what we did in the last section, where we took a look at the tangent function. We saw that the tangent of the angle is equal to the opposite over the adjacent side, right? And that ratio is always the same. It doesn't matter the size of the triangle. The triangle can be really big or really small. The ratio of the sides, opposite over adjacent, depends on the measure of the acute angle. The exact same is true for sine and cosine. Depending on the measure of the acute angle will determine the ratio for the sides of a right triangle. So here's what we're going to be doing. Our essential question, well, now we've already looked at tangent, now we're going to look at sine and cosine. And not only will we look at the sine and cosine ratios, right, solving for maybe the length of one of the sides of the triangle, we'll also look at the inverse of sine and cosine so that we can find the measure of that acute angle, right? What is the measure of that angle based on the ratio of the sides of the right triangle? Again, our objectives are learning targets just like they were for tangent. First, we're going to need to learn how to write those ratios, right? What is the ratio for the sine function, and what is the ratio for the cosine function? What sides do we have to compare? And then we'll go ahead, once we know how to write those ratios for sine and cosine, we'll use it to actually find missing side lengths, or the inverse in order to find missing angle measures. So here we go. Just like we saw in the last set of notes, the last videos, we've got our little triangle right here where we're going to go ahead and take a look at the trigonometric ratios. First, recall from the last set of notes, we already looked at tangent theta. So I'm looking at this acute angle right here. Right? How do I know? Well, because that's angle theta. So tangent of theta, we said the ratio was the opposite over the adjacent. That's the ratio. So the measure of this angle determines the ratio of the opposite side over the adjacent side. Right? Depending on, right, how big or small that angle is will determine the ratio of the opposite over the adjacent. And that's the point of the trig functions. Look, trigonometric ratios, right? So the ratio of the sides of a right triangle is related or depends on the acute angles of the right triangle. So this angle, right, the acute angle, or this angle, right, we just happen to be doing theta, so this angle determines, right, the ratio of the sides of the triangle. Okay, in this section, we're going to go ahead and take a look at the other two trig functions, which are sine theta and cosine theta. Okay, so again, same angle, right? Now, again, theta or a, whatever, generally we're going to call it theta, but we don't have to. It could be sine A or cosine A. However you name that angle, however I name that angle, whatever, it just depends on what's given to you in the problem. Just know there's two different acute angles in here, so we could also do, right, sine of B or cosine of B, where we're talking about this angle right here. Okay, what is the ratio for sine and cosine? Well, let me slide up just a little bit more so that I can still see my right triangle, and these are our ratios right down here. Again, really, just like in the last lesson, this tangent theta is equal to opposite over adjacent. That was really sort of the most important part. Here they are. The ratio for sine, the ratio for cosine. So how do you find the sine of theta? Well, the sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And I know right now you're thinking, okay, hold on a second. Fine, give me one of them and I can maybe remember the ratio. But here's what's going to happen. Now that I have to remember three of them, absolutely, I'm going to wind up mixing up those ratios, right? Instead of remembering tangents opposite over adjacent, I don't know, I maybe forget and put opposite over hypotenuse, and that winds up being sine, right? These are not interchangeable, okay? That's really sort of the point. Tangent theta, you must do opposite over adjacent or you will not get the right answer. Cosine, you must do the adjacent side over the hypotenuse or you will not get the right answer, right? You cannot mix these up. They are not interchangeable. So, how do you keep them straight? Well, there's a neat little mnemonic that generally we use, or that you can use to sort of help you remember. The mnemonic is SOA-KATOA. SOA-KATOA, and here's the way the mnemonic works. The SOA part of SOA-KATOA is sine equals opposite over hypotenuse, right? So the SOA part of SOA-KATOA is sine equals opposite over hypotenuse, and then we have the ka part of SOA-KATOA. That's going to be cosine is equal to adjacent over hypotenuse, so that's the ka part of SOA-KATOA. And then the toa part of SOA-KATOA, of course, then would be tangent is equal to opposite over adjacent, and that's the toa part of SOA-KATOA. So just simply remembering SOA-KATOA should hopefully help you then keep these trig functions straight, and really in particular the part that matters is what is the ratio, right? So sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Just a way of helping you remember which ratio goes with which trig function, because you cannot interchange them, right? You can't put tangent with opposite over hypotenuse and get the right answer. It doesn't work. You can't put cosine with opposite over adjacent and get the right answer. It doesn't work. Cosine goes with adjacent over hypotenuse. So we got to keep those ratios with the trig function that they belong with. Right. So what we'll do on the next page of the notes then is we'll get some practice. I'll give you some triangles and I will ask you to write these three trig ratios for certain acute angles in that triangle. I'll meet you on the next page of the notes.